So this is our last one that we want to do, number 20. So solve the equation. Again, notice we have an equal sign. We said, we got a fraction for each of these guys. We got stuff at the bottom and nothing matches. So we're going to try that trick that we keep on talking about, is how to get rid of the denominator by finding the LCD. So to find the LCD, we got to factor out each of the denominators. Now m plus 4, that's not a monomial, that's a binomial. So the only way to factor out, do we have a GCF? No. Do we have difference of squares? Ooh, right off the bat, because it's plus? No. This one, do we have a GCF? Because it's a binomial? No. Do we have difference of squares? Close. That's a perfect square, that's a minus sign, but that one piece is not a perfect square. So no. And then the final one. Do I have a GCF? No. Remember, because it's a binomial, I have to look for it. Do I have difference of squares? Yes, yes, yes. You got the minus sign, perfect square, perfect square. So then do your two sets of parentheses. One was a plus, one was a minus. Remember, always different signs for difference of squares. And then m, break it down in half, m and m. And then 16, remember, you're breaking it evenly. What two factors are the same? So don't do 2 and 8, because they're not the same number, 4 and 4. Now that we are factored this, this, and this, we'll cross this out, because we want to use the factored form. We're going to write down LCD to get our list. So let's figure out what types of factors at the bottom. This is one factor. Remember, we couldn't break it up. So m plus 4 is one factor. M minus 4. Couldn't break this up, so this is a different type. M plus 4, already on the list. It's a duplicate, don't write it down twice. M minus 4, already in the list. Now if you do the versus game, 1 versus 0 versus 1, you just need 1. 0 versus 1 versus 1, 1. Remember, it's always the most it shows in one denominator. So that's why we do the versus game. 0 versus 1 versus 1. The highest number I said was 1. That's why the exponents are 1. Once you realize what the LCD is, what you want to do is put it on the top. So I'll erase this. I'll stick 20 up here. Make sure to separate your numerators. Put a parentheses around there. That way it makes it easier, so when I put my LCD, I can see which part is the LCD, which part was my original numerator. So each one I'm putting just one m plus 4 and one m minus 4 on top, numerator, for each and every fraction. Now what I'm going to do is see if I can cancel out the denominator with part of that LCD I just wrote up there. In each case you can. So notice there's an m plus 4 on the top, m plus 4 at the bottom. Here, m minus 4, m minus 4. Here, m plus 4, m plus 4, m minus 4, m minus 4. So what's left is this and this. So instead of making it so messy, rewrite it as a regular problem. We have m minus 4 and the 5. Here we have a minus sign. We have an m plus 4. And we have a 7. And here we have just the 12. Notice no more denominator. To get rid of these parentheses, we're going to distribute. So this one's not too bad. 5 times m is 5m. 5 times negative 4 is negative 20. But be careful here. Notice we have a minus sign here. Normally, when there's a sign here, I put a number here. Notice there's no number in front. But we could technically put the 7 in front. Why? Because remember, Doesn't matter if I say 3 times 7 or 7 times 3. The order does not matter with multiplication. You might be saying, well, what makes a difference if I put the 7 over here? Because then I'm distributing a negative 7 out. If you only distribute the 7 this way, you would have 7m plus 28, but then you would have forgotten that you had to distribute the negative. So anytime there's a number, I usually typically put it in front, and then the binomial goes second. And that's why I remember that I have to distribute not only the number, but its sign. So negative 7 times m is negative 7m. Negative 7 times positive 4, negative 28. And then here, 1 times 12 is 12. Now that we have a left side and a right-hand side, we told you, see if you have any like terms. So you can see I have tons of like terms on this side. What are like terms? Variables with variables, constants with constants. Remember, when I collect, I circle. I'm not moving. No opposites here. So 5m and a negative 7m, you know, just combine them by subtracting, you get negative 2m. Remember, I'm not doing any additive inverses. It's not like I add 7 here and add 7 here. You're just collecting. Here, negative and negative, you add. When you add those, you get negative 48. Once you're done collecting any like terms, then this is where you have to do step 7, determine if we're doing factoring or if we're doing variables on one side, constants on the other. And you can see, thank goodness, there's no exponent. So if there's no exponent, then let's put variables on one side, constants on the other, our traditional linear equation solving. This 48 doesn't have a variable, so this is the time that I do additive inverse, where I'm actually picking it up and putting it on the other side of the equal sign. Additive inverses cancel out. So here, positive 12, positive 48 would be positive 60. And then I want m by itself. So you know when I have a coefficient, you do the divorcing step. Divide by the coefficient, including the sign. So you can see I'm going to get m equals negative 30. We just want to make sure that this is the correct solution. Remember, when we're solving this, this only tells me that that could be a possible solution. Sometimes we can eliminate that. The book calls it extenuating one that you can get rid of. Well, I just say look at it, plug into each of these guys, see if these denominators will give you a 0. So if I plug in a negative 30 here, yeah, I get a negative 26, not a 0. Put in a negative 30 here, you get negative 34, still not a 0. Put in a negative 30 here. That might be a little harder. Use your calculator. You know that negative times negative is positive. 30 times 30, hopefully you know, is 900. 900 minus 16, yeah, that's going to give you 884, which is fine, not a 0. So that tells me that this is not extenuating. Basically, this is your final answer.